It's okay. And raise your hand if your math 2 teacher went over piecewise functions. Piecewise functions. Okay, that's fine. We're gonna do it together.
Wait,
Okay.
I don't remember. Oh,
Okay. So we're gonna go over piecewise functions. They're not really a math 3 thing so much. They are an AP pre-calc thing, pretty heavy. We're gonna do some review problems. We're gonna do like one problem of notes. It appears on one quiz, and then we'll be done with it. But I need to make sure you've seen it before AP pre-calc because Mr. Knight and Miss Rice, we just went over the topics and they just did piecewise. So I need to make sure you're situated. It's not hard, and it's perfect timing for us because they have to do with the parent graph summary that we just did, so you understand the general shape. Okay, so the first thing you need to know about piecewise functions is that they have multiple pieces. That's why they're called piecewise. This particular one has 2 pieces. This particular one has 3 pieces. Okay, are you good with that? No. Okay, just meaning, can you tell how many pieces there are? Okay, so what you do is, since there's 2 pieces, make 2 tables. We're going to do these problems all with tables. And label the first table x to x plus 2. That's the first piece. And then x 2 over x is the second piece. Okay, hold on. The zeros help us make the table. So hold on. Okay, we're just getting started. Okay, you got your tables labeled. Okay, now if there's going to be a hard part about this, it's right here. So this is telling you x is less than or equal to 0. Okay, so you start your table with 0, and then you have to go in the less than direction a couple of points. Okay, let me say that again. It says x is less than or equal to 0. You start your table at 0 and go less than. Okay, now this one says x is greater than 0, but you're still going to start your table at 0. Just trust me. The boundary is 0, and then you're going to go in the greater than direction. Everybody good so far? Okay, that's the hard part, is figuring out the x's. Okay, then you do mental math. So 2 times 0 is 0, plus 2 is 2. 2 times -1 is -2, plus 2 is 0. And then because this one's a line, I can tell that it's going down by 2 each time. Okay, 2 divided by 0 is undefined because you can't divide by 0, remember? 2 divided by 1 is 2. 2 divided by 2 is 1. 2 divided by 3 is 2/3, which you can make a decimal if you like. And 2 divided by 4 is 1/2. Do you want me to actually put my work though? Hold on. Okay. What? Why are you laughing at me? Oh, I'm so dumb. Okay. All right. The last thing before we graph is we talk about the boundary points. Okay. And we have to focus our eyes up here. This represents a closed circle because it has the or equal to, and this represents an open circle because it doesn't have the or equal to. Okay, so what you're going to do is go back to your table. I like to circle my boundary points. This one is closed. this is going to be open. Clearly, you can't grab it anyway. Okay, do you guys see where I got the closed and open from?
Yeah.
Okay, so start here, graph 0, 2, and make it obnoxious. Like these boundary points, make them big, like closed or open. Okay, -1, 0, make that like a regular dot. -2, -2, -3, -4, -4, -6. And then notice where the pattern's going. It's going this way. So keep the pattern going with an arrow. Okay, then this is kind of weird, so skip that for a second, just for a second. Go 1, 2, make a dot. 2, 1, make a dot. 3, 0.67. Okay, now you guys know what the shape of this thing is? What kind of a function is this? Rational. It makes a hyperbola. So it's going to come along the asymptote and go like that. And don't worry about this open circle thing because there's an asymptote there anyway, so it's never going to touch it. It's not that bad. You just make a couple tables. It does look scary. I think it looks fancy. Yeah, there's stuff going on for sure. Okay, now scroll yourselves down to 17 and 19. And these are special right triangles, 30, 60, 90, 45, 45, 90. Okay, does anybody know the formula for a 45, 45, 90?
45. Actually, I don't like it.
Yes, yeah. Beautiful. Couldn't have done it any better myself. X, root 2. Okay, so that means this is 5. So this is 5. So this is 5 root 2. So m equals 5 root 2. N equals 5. Yep, 30, 60, 90 is what? X is the short side. 2x is the hypotenuse. Nice. What's the other one? Gotcha. X root 3. Perfect. Okay, so that's x. So this side is 8. So this side's going to be 16. And this side's going to be 8 root 3. So u equals 16. V equals 8 root 3. Okay, now do all of you know that there's like a forwards direction and a backwards direction of these problems? You realize that those were the two easy styles. So if the whole number is on the one with the root, you actually have to do stuff and things. We're not doing that today. We're going to do it Monday, but just trying to throw that back out there. There's like you have to go backwards. Okay, just anyway. It's not bad. It's not bad. Okay. So we are doing problems 89 to 92. 89 is in the notebook. What? I don't know what happened. I didn't finish my graph. So today, you know how like on the block day, I taught you how to do things with the graphing calculator, graph stuff. Okay, today is about two types of graphs that you can't graph in the graphing calculator. These two are non-functions, which means they're fancy. But what I want you to notice on this one, usually parabolas are y equals x squared. This one is x equals y squared. Which means if you look in the graphing calculator, if you hit y equals, you have to put everything in y equals form. This one is x equals, so you can't do it. Yeah, so sadly, you can't graph this on the graphing calculator. You can do it in Desmos. If you type x equals y squared, it will do it, but your graphing calculator won't. I will teach you a cheat for it later, but for now, can't do it. Okay, now let's pretend we did want to do it because we just wanted to cheat. And we want to make a table. So what I'm going to do is take my x equals y squared over here, and I'm going to get y by itself. How do I undo a squared? Square root. Okay, however, what do I have to remember when I square root both sides? Yes, okay. So this is kind of the cheat. You could do y1 is square root of x and y2 is negative square root of x and graph it, but it's not going to look right. Okay, so up here, right, equals plus or minus square root of x. And we're going to do our table from -2 to 6. Okay, so plus or minus the square root of -2. Can I graph this? What's going to happen in the calculator if I do square root of -2? Error, right? What about this? Error. What about this? 0, but there's only one answer. There's no such thing as +0 or -0. It's just 0. And this is the coordinate 0, 0, which is right here. So graph that. And then after this moment, you're going to start picking up what I'm laying down. Okay, plus or minus the square root of what? What's the square root of what? 1. So plus or minus 1. Okay, so you need to put a coordinate at 1, +1, and another coordinate at 1, -1. Oh. Okay. Okay. Anybody know an approximation for the square root of 2 right off the top of their head? Yep, it's 1.4. Great job. Okay, so we go to positive 1.4 to negative 1.4. Does anybody know the square root of 3? 1.7. Here's a nice one. Yep. Okay, I think you're getting the pattern from there. So do your best. Sketch. And this guy is called a sleeping parabola. Literally, that's the name I'm going to call him all your sleeping parabola. And it's just a parabola that fell over and fell asleep. Okay, now can you grab your blue pages? So we're going to fill out 2 entries in the blue page for number 90 and number 91. So if you colored it and whatnot, get that stuff out. I will do the same. Hmm? Yep.
Yes.
Okay. Now sleeping parabolas are complicated, so I'm going to ask you to focus. The next one we do, this one is easy. This one, sleeping parabola is the hardest one. So because everything is wonky, so we just need to go very carefully. Now, what do you notice about the x and y versus a regular parabola? Yeah, they're flipped, right? So the equation, you flip them to, so x equals is in the front, not y equals. A is still in the front though of the parentheses, but in the parentheses is y minus k squared, and then h is now outside. Yeah, that's why you're going to be happy to have this set of blue sheets. Yeah, you can make a note card and put things on it if you want. So, okay, sleeping parabolas have a vertex. And it's still HK. That part doesn't change. Vertex is still HK. And thank goodness there are no asymptotes. That would be even more horrible. Okay, pausing there. Anything you want to say about those first four boxes? Okay, now we're gonna sketch it first and then do the rest of the entries off the sketch. So we sketched it in number 89 and it looks like this. Okay, and just to remind you guys, as x goes to negative infinity is the left arrow. There is no left arrow. Shh. So there's no left end behavior. And I'm going to make sure that I mark that for a positive A, which is what we're doing right now. Now there are two right arrows. This one's going up, this one's going down. So what I'm going to say for the right arrows is plus or minus infinity to count for both of those. Just like the plus or minus we did in our roots. Okay. And the domain and range are flipped for a regular parabola. So the domain actually has two options. And the range is all real numbers every time. But since the domain deals with x, x is greater than or equal to h, x is less than or equal to h if it's a negative a, which we're going to actually look at in a second. What do you think is going to happen to the end behavior with a negative a? Yeah, they're going to flip. And then we'll graph one in a second. Okay, now with your other color, find the point 3, 4, the same 3, 4 you've been using. And then since we can't graph this on the graphing calculator, we're going to put it into Desmos. So let's take a look at where they should cross some things. Okay, so x equals y squared. There's my original one, except for I made that one a different color. I made it black. Okay, so x equals negative 2 y minus 4 squared plus 3. Okay, so you've got your 0.34. So notice it's like a little bit skinnier. Mine's not great. I must fix it. Ah, I have an erasable pen. I cheated. Okay, now last entry that we're gonna do the one on the back in chapter 5, I believe. Yes, the one on the back is gonna be in chapter 5. So just please don't lose these papers. You don't want to lose them anyway, 'cause that would be a terrible idea. But we're gonna do that one in chapter 5. I guess. The back one in chapter 5. Okay, now math 2, what is this? I heard it. What was it? Circles. Okay, and circles have a little bit of a different equation. So x minus h squared plus y minus k squared equals r squared, where r is the radius. You did circles when you did completing the square, because you have to complete the square twice. It's like double complete the square. And circles do not have asymptotes. Okay, here's a fun fact. Circles don't have end behavior because they don't have ends, which is awesome because then we don't have to fill that box in. Okay, and now I'm going to give you a formula for domain and range that I'm never ever going to use because I'm just going to look at the picture. So, but I'm going to give you a formula. It's way more complicated than just counting boxes, but there it is. If you ever wanted to have a formula for domain and range of a circle, there you go. But it's really complicated and not necessary. Okay, now we're going to graph our circles really weird. So first thing I want you to do is find the 0.34. I know that's weird because we're starting with the color part. Okay, now the reason I wanted you to do that is because when you graph your 0.34, you can figure out how to scale the x-axis out to 3. That's terrible. I can't, I'm just absolutely incompetent at making this into 3 equal pieces. Okay, it's the worst thing I've ever done in life, but whatever, all good. Fine, it's on video, preserved forever now. Okay, so we're gonna graph the parent graph circle, which has a center of 0, 0, and a radius of 1. So start with your original color. Put a dot at 0, 0, and then a radius of 1. Okay, I kind of redeemed myself there. Okay, so keep that in mind because all of our graphs are dilated by 2, so we're going to make our radius 2. So try to figure out what a 2 radius would be using your little scale here. AP art class today. I'm kidding. Okay, so remember, center is 3, 4, and the radius is 2, but in the formula, it's r squared, so 2 squared is 4. Okay, now after you get this situated, head back to the notebook for number 92. It's really not my best work there. It's fine. It's really okay. I just need to figure out how to live. Yes, what? I tried. I did try. You would think though, like, I don't know, been doing this for quite some time. Okay, here's number 92. It's constant. Yeah. It's all good.
Why are we starting at 92?
89 was the sleeping parabola, the big one.
How come at
90
90?
and 91 were this and this.
Oh,
I put it at the top of the.
sorry.
All good.
I don't know what you said, I just wrote that down. So I'll give it.
Okay, so this problem is going to be very quick. We're going to do four things. We're gonna figure out the locator point. We're gonna figure out the radius. We're gonna graph it, and then we're going to find domain and range. So those are the 4 things you usually do with a circle. And this is very easy, and there's really no work to do, but we just need to look at the equation. So first thing we're gonna do is find the locator point. And from my blue sheets, it says that the locator point is the center, which is h comma k. Okay, so that's the center. And remember, you're coming out of parentheses, so you have to switch signs for both. So 3, -2. Okay, and then graph the point 3, -2 for your center. Everybody good so far? 3, -2. Okay. The radius is the square root of 16, which is 4. Remember, the formula is radius squared, so you have to square root it to get the radius. So what you do is you count 4 boxes every direction from the center. So 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. Now, generally, the bigger the circle, the worse I seem to graph it. So, yeah.
Oh, you're so good. Why are you guys making perfect circles and mine looks so orange? This is good. Look at mine.
Usually, they either come out looking like a potato or Stewie's head or just a square with rounded edges. Anyway, okay. Now, you know how I gave you that horrible, horrible formula for domain and range? Let me show you what to do instead of that. What you're going to do is just figure out that this is the left and this is the right. So -1 is less than or equal to x is less than or equal to 7. And then you're going to figure out what is the bottom and what is the top. think it's positive 2. But that's so much better than the formula. Just count.
I mean, she said, I think it's positive. Obviously.
Well, I second guess myself again, yet again. Okay, so that's all done. Can you find the stamp sheet, please? Stamp sheet.
Yes, because I have a bunch of stuff. Okay. I was not
I'm fine. I like filling in the boxes. Okay. So, do you guys see the blue check marks? Those are the things that I would like to stamp. There are 1, 2, 3, 4, 5 of you, of which I did not receive your digital escape. So I will not be stamping that digital escape box for 5 of you. For everyone else, I will. So this is, you don't have to show me anything for this box. I have it from Google Classroom already. You can show me. Everyone did it in class. You remember how easy it was? You didn't? Okay, awesome. Okay. Then these 2 homeworks and these 2 notes. Remember number 70 is in the packet. It's the highlight page with the columns. Homework is 102, 103, 106, and 108.